Hello, hi guys. Today we'll be discussing something about a project which is on PyPI dependencies. Analyze the dependencies in PyPI metadata. We'll be getting a metadata for each and every package in a Python. There will be some dependencies. The each and every package which is available on Python, that package will be depending upon the another package of a Python. So we'll be discussing the dependencies of this PyPI using something called NetworkX, which is a Python package which is used to analyze this network or to analyze the network or complex type of problems. We'll be importing different type of packages in order to read this data, where we are importing something called as pandas, as PD and matplotlib for visualization purpose, and numpy for math purpose, and for Seaborn, which is used for visualization purpose, and NetworkX. I'll tell you about NetworkX after a minute. So, and the operator which is used for sorting kind of thing, and matplotlib inline, which is for representation after the command. Okay, and I got this information. I got this data from the Kaggle platform, which is a competitive platform or ML problems. I have read the problem and I have derived this column, that is package and requirement, and package name and the package version. We are mainly concentrated on these two things, that is requirement and the package name. What is a package name and what are the requirements for that package name? We are mainly concentrated on that, and we are building the network on this using package name and their requirement. And the package and the package version is not necessary for this. Here in this we are going to in order to get the information of any data, we have to write this code, that is data.info, which gives the information like a number of entities and a number of columns in it, and what type of data. For example, object type of data or string type of data, or uh, numerical integrated kind of data, or a float data type something, and how many datas are present. I mean, for example, here the number of entities are 11,104 entities, but here you can see that requirement has only 707 73,773, and this says that some are missing values in this requirement. Okay, and here also there are only sorry, 1,08,000 something. Okay, here is a code in order to know the null values, and to see the null values, and how to check the visualization of it. The data.isNA.sum gives the number of missing values, and in each series, or we call it as columns or series. Here you can see requirement as 36,331 null values, and package name column consists of 1,200 plus null values, and package version consists of 1,200 plus null values. Here you can see the visualization of the null values. Here you can see the white spaces in this block diagram. The white spaces represents there are a missing values. These are a missing value. The white spaces represents the missing values. Okay. About the NetworkX. NetworkX is an Python package software used for creation, manipulation, and study of structure, dynamics, and functions of complex networks. And you can see the Python language data structures for graphs, digraphs, and multigraphs. You can see here we are using this NetworkX in order to analyze this data in a network type of thing, or else we can say that in a digraph, I mean directional graph. NetworkX is representation of any data in a graphical representation of any ray is known as network package. Network package is usually used for graphical representation, whether it may be unidirectional or digraph. and it consists of mainly two components, which are nodes and edges. And there are two types of graphs in NetworkX, that is digraph and unigraph. Digraph is nothing but directional graph, and unigraph is nothing but there is no direction in that graph. In the starting itself, I want to tell you that there are two main things which are in this network. One is nodes. Nodes are nothing but the points or a vertices. Let's say in this example, the package name is a nodes, and the interconnection between these nodes is known as edges. We are connecting each and every node. I mean, this uh, the nodes which are connected interlinked. There is the line which is passing between two nodes, which is known as edges. Okay, here you can see I am using edges is equal to data.ilog, and requirement is not null, and uh, the line they just mainly require two things. One is from which node to from which node we have to pass the line, I mean pass the link. It requires that one. So I have given data dot requirement. The requirement has more null values, and I have given that select the data which has not null, and from that data I have to extract this package name and this package name and this requirement values. Here you can see this is a package name and this is a requirement. From this package name to this requirement, I have to pass something line which is known as edge. And at the starting, we next we'll be coming to something called as degree. Okay, here we are here we are creating something called graph object. You can see dg is equal to nx dot digraph. Digraph is nothing but I said you already, that is directional graph. I can show you an example. 1 minute. Huh. Here you can see there is a arrow marks. Arrow marks is saying that from this node, one edge is going to this node. The interconnected, this black lines, you can see these black lines. Black lines are known as edges. This blue blue circles are known as nodes. From this node, it is going to this node. This arrow mark shows that it is a directional. From here to here, it is going. If there is no arrow mark, then it is known as unidirectional or just a graph. Okay, here I am creating a digraph, I mean directional graph object, and I am adding the different types of, I mean I am adding the nodes to this graph. Here you can see from this I'm created a function which is known as make graph. From there have passed something called data and minimum number of edges, and I have given something called minimum number of edges. Why have I given minimum number of edges? I'll be explaining that. Okay, here I have created something called digraph, which is known as digraph is known as directional graph object. Okay, directional graph object. From there I am adding something nodes, that is dg dot add nodes from, this is nodes that I have added. Then I have added something called edges. Edges, I have explained you already how the edges are been derived, and I have added the edges by using something called add edges to this digraph. And I am removing the bad edges. Bad edges is nothing but some edges which has null values or dot values or values which has nothing. And you can see I'm removing some nodes which has zero edges. The nodes which has zero edges, there is no use of it. Why? Because it is not I can we can say in a family each and every person is connected with some of a relation. Okay, for example, in a family each and every person is interlinked. Each and every person is interlinked with the help of something called relation, like daughter, son, mother, grandson, something like that. If a person who is a stranger who is standing over there, and there is no relation between this family and that stranger, hence we are dropping that stranger. In the same way here, if any package which doesn't have any dependencies, that package we are removing in order to analyze uh, we are analyzing the dependencies, no, hence we are uh, removing that package which has no dependencies. Okay, this is a syntax for dg in degree. Degree represents dg dot degree of any node gives the number of edges for any point, any node. Here dg dot degree, and I am passing n is nothing but the node name. Okay, the node name here, suppose take it as a node name. The for especially for this node, how many number of degrees, in the sense how many number of links are there, how many number of edges are there, it will define that. If it is 0, if it is less than 0 or 0, not me in it, it will not be less than 0, it is 0, then we are removing that node. And we have right now we have something called, we have created a digraph with nodes and edges, and we have removed all the bad nodes and nodes which have very less edges, that is 0. And we have created something called graph using a data, and we have written that graph element by using something called dot, make dot or write dot, which is on something called, which is a small text file or small dot file, which will be created in the back end of this particular of this project or this Python project. You can see, if you type dg.nodes, here it will tell that how many number of nodes and what are the names of the nodes. And if you type dg.edges, it will define how many edges and what are the edges names. Okay, then we'll be moving to something called EDA, something called exploratory data analysis, or we can say some stats and visualization part. Here firstly we are doing something called histogram and number of connections on top several packages. Is nothing but the top packages which is having more links, we are plotting that. We are plotting by using something called degree here, nx dot degree, and nx dot degree parenthesis. In that parenthesis we'll be passing something called node name, so that it will define how many number of connections it will define. I mean, it will find out the how many number of connections that the node has. Here I can tell you. Wait for a second. Here I have given something called, here sorted dict. I am uh, creating some dictionary which is sorted in nature, and I have taken that by graph object, and I have graph object, and I have given in degree. In degree is nothing but number of connections, incoming connections. Okay, incoming connections. And here I'm using something called key and operator dot item getter in order to sort the dictionary depending upon, I mean, depending upon the value, not upon the key. Severally, if we sort any dictionary by direct sort, uh, it automatically defaultly sort the dictionary based on the key. But here we need the dictionary to be sorted with the help of, I mean, depending upon the values. Hence I have given something called operator dot key item getter, that is one which is known as index number. Okay, and I have given top 10. I just wanted to figure out the top 10 connections which are having a top 10 packages or top 10 nodes which are having high connections. Okay, then I have a given arrange np dot arrange. It arranges the 10, that is from 1 to 10, it arranges in array. Then why I have given something called d in a sorted. Here I have sorted. Okay, here I have sorted, and I have sorted, and then I'll be giving the value of sorted components, that is d1. This represents the number, how many number of that, especially that package has. And I have given a labels. Labels is nothing but how top levels and then top packages or top 10 packages. Here I have given something called fig.ax subplots. I have given subplots, that is 1 comma 1, and figure size, how much the figure size will be deciding here. And I have given something called bar h. Bar h is nothing but all the plots of a bar, kind bar will be in vertical, but I just wanted to show it in horizontal, hence I have given something called bar h, which gives which visualize the data in horizontal way. Okay, then I have given x labels, the name of x-axis and y-axis, and the title for the x-axis. Here it represents it is a graphical representation of graph degree, or a graphical representation of how many number of links or how many number of edges does this package has. I mean, the top packages which has many connections or which has many edges. Here you can see the request has many links or connections, and the second one is distribute, then django 6. These are the some of the nodes which has high number of connections. Okay, coming to page rank. Page rank is a very important topic, very important topic in NetworkX. Here you can see a page rank. Assume there are several. Assume a Google. There are several web pages for a single search. These web pages, we have to rank these web pages depending upon their efficiency. This has yielded a 450 billion industry for a Google. They have introduced something called PageRank. They will be giving a PageRank for each and web page depending upon the search item or depending upon the interconnectivity between the search. So they have given a PageRank depending upon something called link analysis, link analysis, depending upon something called link analysis, and between a centrality and centrality measures. They have given a page rank to each and every web page, so that if you are searching for anything, first this web page will come. Okay, depending upon the efficiency of a data, depending upon the interconnectivity between the web pages, the web rank will decide which as a more power or more importance. Okay, coming to the code, have given something called page rank is equal to nx dot link analysis of a page rank of that graph object. Then I have a sorted a list. Then I'll be getting something called dict item from the this page rank. Then I have sorted this dict item, dict dictionary. Then I have sorted in this dictionary. Then I have I have to sort this dictionary by using by depending upon the values. Then I have decided to do that. Then I have given subplots and the figure size, and I have arranged the code for plotting as same as histogram. Here y which consists of values, and which x which consists of the package names, and the bar should be in horizontal way, and some of x labels, x-axis name and y-axis name, and the title name is given. Here also you can see this graph. The graph, you can see the request as a more page rank. I mean, page rank is one for request and distribution, and the page rank will goes on. It tells that request has more power when compared to all other nodes or all other packages. Okay, coming to highest centrality, degree centrality. Coming to centrality. Centrality is nothing but a measure of connections, or measure of connections, measure of what you call measure of distance between one node to another node, or one node to another node, is known as centrality. Here there are so many types of centrality. One is degree centrality, and between a centrality and closeness centrality. I'll be explaining about that, and I'll be uh, writing a graph, or I'll be viewing a graph with respect to that centralities. The first one is degree centrality. Degree centrality is nothing but how many number of connection does the each node has. It tells degree centrality tells that how many number of nodes or how many number of connection, how many number of how many number of connections or how many number of edges that each node has. Here you can see degree cent is equal to nx dot degree centrality of a graph object. This can be done only by not this can be done by using a graph object, not digraph object. That is, it accepts only unigraph object, not directional graph object. Okay. Then I have given here centrality measure. That is, this is something called definition. This here centrality measure. This is something called a function which is created in order to sort the obtained dictionary. Here I'll be getting a dictionary for each and every thing which and every result which I just wanted to obtain. If you see here degree cent, and I am getting the degree centrality of each and every package. This consists of package name and how many number of nodes. Thus each node had. This data will be this data will be stored in something called dictionary. This dictionary has to be sorted in order to get the top several packages. Okay. Then have sorted the packages which I have got, and then have I just wanted to graph these top packages. I have selected 50 top 50. Here you can see degree centrality of degree centrality. Phoenix as highest degree centrality. Coverage is a second one, 6 is a third, mock is a fourth, and goes on. Here you can see the top 50 nodes, and there is an interlink or the edges which are connected to these nodes. Means the some of the nodes, the here you can see these nodes are elaborating more, in the sense these nodes are this node are sending information. This node is depending upon this node. Okay. The next coming to next topic, which is now betweenness centrality. Betweenness centrality is nothing but the metric is measured with the number of shortest paths. A metric is measured with a number of shortest paths. It's nothing but here we'll be finding something called shortest paths of each and every node to node. Okay. Here's something called I have used something that nx dot betweenness centrality of graphical object, and I have used that graphical object, and I have sorted that graphical object dictionary with the help of values, and I have sorted the first 10 objects. Here you can see PBR, which is having the highest between a centrality, and which is a short path, and mock, and goes on, hacking, and goes on. And we'll be coming to something called in order to draw this subgraph. I have drawn this subgraph. You can see this is a subgraph of top 50, which is having a high centrality, high betweenness centrality, which is shortest in nature, short path. This closeness centrality is nothing but a way of detecting nodes whether they are able to spread the information or very efficiently through a graph or not. Uh, Closeness centrality is referred to something called spread information with efficiency. Or I can tell you an example. We have communities. In that community there will be something called head. A head, if news will be passed to head will pass the news to whole community. The speed of or the information spread is very fast, and it will be efficiently spread the data. Where if any person in that if there is any person in that community who is not head, who is a simple person who knows the information, who wants to spread the information. He wants to spread the information, but he can't able to spread the information because he don't have that much of network in that community. The finding the closeness centrality is nothing but finding the node which has more importance and which has a more spread information efficiency. Okay, so you can see closeness. You can see these are the top nodes which has a high closeness and sensory declarity, which can pass the information at a greater extent. This is the integrity centrality for how they are interlinked with the top packages. This is out degree is nothing but this number of incoming connections, this number of outgoing connections. Okay, in here you can see here one government onboarding is sending information to one board, one government town. Community graphs will be explaining about these community graphs in the later stages. I can explain here I can explain something called how this basic understanding of community graphs. Community graphs is nothing but we have a large network. Let's suppose we'll take something called mm Facebook. We'll take something called Facebook. Facebook Facebook has a large number of connections, but it can be divided into something called communities. India has some community, Karnataka has some community, Bangalore has some community. These communities, dividing this whole network into subparts is known as community, so that each community has more power. Okay, each world small graph is this small world graph. In here, I'll be explaining something about clustering coefficient and small path lengths. 1 minute. In order to search any node, in order to search any node, we have to do something called in order to search any node in a minimum number of steps, that is log n steps, we have to use something called small word phenomena. Okay, and there are something called link prediction and contagious, Aquantius, and strength of weak ties, and we'll be explaining about that in later stages. Stay tuned. Thank you very much.